Hello everyone, in this video let's solve the problem police and thieves. So this problem is from Geek for Geeks and it says given an array ARR, they have given an array ARR which whose type is character, where each element contains either a P for policeman or a T for thief. Find the maximum number of thieves that can be caught by the police. Got it. Keep in mind the following conditions. Each policeman can catch only one thief. Okay, so one policeman can catch only one thief, and a policeman cannot catch a thief who is more than k units away from him. Okay, so there is a distance constraint as well. So I'll explain. Don't worry on the board. Uh, so they have given a first example. So which is P, T, T, P, T. P is for police, T is for thief, K is 1. So maximum distance that can be that police can catch him is at distance K. So let's take this and try to understand what it is saying. PTT. So they have given an array and k value is 1. So this is the array that they have given. Said in the question what they've asked is P is for police, T is for thief, and each police should catch a thief. So in this case, if you see, this police can catch this thief because this is 0, 1, 2, 3, 4. These are the indices of the array. So if you take the difference of these, so 1 minus 0 which is 1, so it is a distance 1, and which is within they have said the distance would be at most k, not more than that. So at most k means it can be either 0 or it can be either 1. So it is 1, so we can these police can catch these thieves, so that is fine. Now coming to this police, so if you see, let's take that this police which is index 3 is trying to catch thief 4. So in that case our distance will be 1, 4 minus 3 which is 1. So he can catch this one. Also if you try to see this one, that will be 3 minus 2. Again distance is 1. Again he can catch this as well. But in question they have given he can catch only one thief. So let's take he is catching the right thief. Okay. So in this case, there are two police and both the police can catch thieves according to given two conditions. So in this case, you will have to return basically count as 2, which is 2 thieves can be caught. So I think how do you solve it? Okay, there are two approaches which can be solved. So one approach will be a brute force approach. So I'll tell you this is basically a greedy solution. Why it is greedy? Because if you take any police, right? If you take any police from left to right, if you are taking from left to right. So if you take any police from left to right, say this left police whatever is there, he will try to catch the thief which is leftmost to him and within the range that the distance is k that they given. So this is why greedy I'm trying to say that let's say at this particular index, let's say x police is there and one more at index let's say x1 thief is there and one more at distance let's say x2 police is there. So if like this police will try to catch the thief which is leftmost to it, so let's say this police will catch this thief, so this police cannot catch this thief, reason being he is already caught it. Okay, this police have already caught it, but let's say this distance whatever is there x minus x1, this is d is the distance and which is greater than k. In question they have given distance has to be less than or equals to k. So in that case this police cannot catch this thief and also this cannot catch, this police also cannot catch. Reason being, if in a number line from 0 to n, so basically the indices, so x minus x1 is a particular distance and x2 minus x1 is distance 1 which is greater than d, obviously, right? Because this is constant but this is at the right side at some value and this is more than that, so he will also not be able to catch it. So that is why this is greedy. So you'll have to try to get the thieves from the left hand side, try to catch thieves from the left hand side, and also the left hand side the police will be trying to catch the leftmost thieves. I think you got this problem statement. So this is basically uh, mathematics solution. It will say that this is a greedy. So there are two methods that can be solved. One method is that one method will be a brute force solution. In that case, what I'll be doing is basically we will be iterating from left to right each police. Okay, let's take this police, or let me take one more example, the second one, which is TT, PP, TP, TT, PP, TP, and K value they have given is 2. So this is the second example what I'm taking. This is our index 0, 1, 2, 3, 4, 5. So we will run a loop, for loop basically, which will be running from 0 to n. Okay, and we will find if this element, which is array of I basically, if that is equals to p, which means police. So we'll try to, because police will catch thief, so that's why we will first take the thief, first occurrence of thief. So we will traverse through the loop, we will get here one police. Now since they have said like this has to be, this police has to catch the thief which is at distance at most k. So this will be distance 1, this is distance 2. So in example they have given k is 2. So our left range will be p minus k, right? That will be 2 minus k is 2, which is 0. So our left range will start from 0. This is at say, let's say distance 1, this is at distance 2. So it will start from here only. Okay, and let's say if k value was 3, so in that case what it would have been k minus 3, and this will be minus 1, so which is beyond the integer range, right? So to handle this minus 1, what we'll do is left range, our left range will be from, which is max of 0 to p minus k. This will handle the outbound case also. If it is beyond that, so in that case we'll start from 0 only. So whenever we get the police, so we'll take the left range, let me write LR, left range as max of 0 comma p minus k. Now we'll try to find what is the right range. It can go to two distance, 1, 2. So how can we do that? So right range RR, that will be p plus k if you do. So p is basically in this case about 2 plus k is 2 again. So that is 4. So which is correct. This is a distance 1, this is a distance 2. So our left and right range is perfect. But what if let's say k was 4? So in that case this is 3, distance 1, distance 2, this is distance 3, and this is distance 4. If k was 4, so it would have been 6, and it will go out of the range integers. So if it goes integer out of the range, so you will have to somehow traverse till the bound only. So in that case we will take right range is equal to minimum of n minus 1, which is last index of the array, comma p of k. This will give us the index. N minus 1 is basically 5, and p plus k in this case is let's say 6. So this will travel till the boundary only. So our right range will be this particular thing. Right range will be minimum of n minus k, right side's boundary, comma p plus k. So minimum of these two will be our right range. So we have got for this police left range and right range, okay, which is this thing. So what we will try to do is from left side only we will try to find the thief, because as I said previously. Like for this police, we'll have to try to find the leftmost thief, so that that thief will be caught by this police. And when we move to the next police, at that time again this thief is already caught, so we will put in visited vector basically, or caught vector you can say. This will be a vector of boolean type. Okay, so we will store in that, and we will try to find if this is the thief which is not caught, then we'll take it. If this is caught, then we'll try to take next leftmost thief, right? So basically after this finding, we'll write a for loop that will start from left range till right range. Okay, and we will find if not of caught basically is an array which keeps track of the thieves which are caught. If not of caught of I, which means it is false. If this is false, and not of that will be true. So if this is the condition, and we'll do what is array of I is equals to thief. T is denoted as thief. So in that case, we have got a leftmost thief. So we will basically put this in a caught vector. Caught of I will be true, and we will increase the count by 1 and break it out. Why increase count by 1? Because we have got one police have caught one thief, so count is basically a variable which keeps track of how many thieves are caught. So we'll come out of the loop, and this will again try to run for the next police, and it will run for all the police and try to catch the thief. And at the end, after this for loop, we'll have to return this count. Got it? So I think this is easy only. Let me try to code it up. So first thing we'll have to do is we'll have to take n, which is basically array dot size. Now we will be taking one for loop, as I said. So if array of I is equals to p, which means we've got a police. Now we'll try to find the leftmost thief. So start index will be maximum of, as I said, 0 comma p minus k. Okay, this will be a start index. End index will be minimum of n minus 1 comma p plus k. So we'll run a loop j, which will be running from start index to end index. Okay, so now we'll try to find if one vector will take caught, basically vector whose type is boolean, caught of n. By default, if you don't initialize any value, it will be false. So we'll have to figure out here if caught of I equals to false, which means this thief is not caught. And we'll see if array of j is equals to thief. So in that case, we'll have to basically we have got a thief right now. So caught of I will be initialized to true, and count plus plus count we have not taken. Basically we'll take one variable count. This is keeping track of how many thieves have been caught. Once we caught a thief, we'll break it up, because one police can catch only one thief. So for this police which is present in index I, we have got a thief. This all will be j, basically. My bad. So for that particular police who is present at I, that police is catching a thief which is present in index j. So once we caught one thief, so we'll break out of the loop, and at the end we'll have to return this count. Let's try to run the code. P was not declared in the scope. Acha, P, it is not P, it is I, because police is at index I. So it is running fine. Let's try to submit the code. So as you can see, it is giving TLE. Reason being, this loop is running for n times, and this loop is running for k times, because 2k times. Because let's say this is a point wherein police is there, so previous k elements will take and next k elements will take, so that will be 2k, and middle element one more is there, so 2k plus 1. So let's try to understand why it is not running. So array of size is 10 power 5 and k is 10 power 3. Let me take you to the board. So basically this loop is running for n times, and this loop is running for 2 star k plus 1. Okay, so what is in question? They have given n as 10 power 5 and k they have given as 10 power 3. So if you try to take, it will be 10 power 8. So 10 power 8 means it is not within 1 second. So this problem is giving us TLE. So in this video I have solved a brute force solution. In the next video I will be solving how to solve this problem optimally using 2 pointers. So that will be displayed on the bottom left side. So you just click on it and then let me try to explain in, because this video is very lengthy, that's why.